So 11.2 and 11.3 introduce kind of the two most common forms of sequences. So 11.2 is the arithmetic sequence, and I'll just read the definition here. An arithmetic sequence is a sequence that has the property that the difference between two consecutive terms is constant. That constant is called a common difference. And so what we'll see with these is kind of like the last example, or second to last in 11.1. When we look at this list, we'll see that they're increasing by the same amount every time. In other words, they're linear. And the nth term formula, and this is super important, this is one of the two things we'll see in 11.2 and 11.3. And this is kind of the workhorse of arithmetic sequences. So the nth term formula is given a sub n, let me write this bigger to make sure you guys can see, equals the first term plus n minus 1 times d. A sub 1 is the first term, and then d is the common difference. So this thing, anytime it starts talking about, it's an arithmetic sequence and something about find some term, this is your nth term formula. So this is the one that's going to let you find terms. The other thing we'll see in these two sections is sum formulas, so for like adding up the sequence. So that's going to kind of be our first thing that we have to figure out when we're in these sections is, what are we looking for? Are we trying to find a sum, or are we trying to find a term? And if it's term, this is the formula. So these first ones are just kind of playing with this definition a little bit. So determine if the following sequence is arithmetic. If it is, identify the common difference. So to find the common difference, I just start checking to see if it has a common difference. So 7 minus 3, that would be 4. 11 minus 7, that would be 4. 15 minus 11, that would be 4. So this we would say, yes, it is arithmetic because it has a common difference, and that common difference is 4. Looking at this one, 4 minus 1 would be 3, 9 minus 4 would be 5, and right there, not going to have a common difference. So we would just say, no, it's not arithmetic. So for number 2, given the first term, a sub 1 is 7, and the common difference, find a formula for a sub n, sort of try finding an nth term formula, and then find the 17th term, a sub 17. So a sub n, we have this is our nth term formula up here. So a sub n is going to equal the first term, which is 7, plus n minus 1, and n is our counter, so it just stays n. It's like the x. And then the common difference they told us was 3. And so then I just have to clean this up a little bit. And a sub n will equal 7, 3 times n, 3 times 1, and 7 minus 3. So then a sub n equals 3n, 7 minus 3 will leave us 4. So this is a formula we'll find any term in this sequence. And I can do that by just picking whatever n I'm interested in this case 17, and then plugging 17 into the formula, and then calculating. And so if we throw that in the calculator, that's 51 plus 4, or the 17th term is 55. Question 3 is, given the arithmetic sequence this, find the 40th term. So first off, we need, up here we had the first term and the difference. Right here we have our first term, it's 9. So a sub 1 equals 9. And then our difference, 9 to 13, so 13 minus 9 would be 4. 17 minus 13 is still 4. So our common difference is 4. And then we can do kind of the same as we did here, but with this time we know, n is 40 is what we're aiming for. So I know the first term, I know d, and I know n, and then that's going to let me find the 40th term. So a sub 40 is going to equal the first term, which was 9, plus n minus 1, but this time we know n is 40. It didn't ask us to find the general form. We could, and then just plug in n, or you could do it all at once. And d in this case is 4. So a sub 40, 9 plus 39 times, 4. And if you plug that in, we get the 40th term is 165. So then the next formula in the section, there's actually two forms of it, is the sum of the nth term of an arithmetic sequence is given by either here or here, where a sub 1 is the first term, d is a common difference, and then s sub n is the sum through the nth term. So say I want to find the sum through the first 36 terms, then n would be 36. So here they're giving us a sub 1, d, and we're supposed to find the ninth term and the sum through ninth terms. So I'm going to use that formula again, which is the a sub n equals a sub 1 plus n minus 1 d. So that's our nth term formula. And on this exam, you absolutely get these formulas, so you don't have to memorize them, but you do have to know what to do with them. And so this is where we have to determine if I'm finding a term, I'm using nth term. If I'm finding a sum, then I'm using one of these sum formulas. And this one's kind of a two-part, we're finding both. So the ninth term, a sub n, a sub 9, will equal the first term, 3, plus the difference, n minus 1, 9 minus 1, and then the difference, 7. And so kind of grinding this out, I get that the ninth term is 3 plus 8 times 7, and that'd be 56, 59. So the ninth term is 59. And I can use either of these two formulas. I'm going to use the one that's a little bit less complicated if it's available to me, and in this case it is. So I can say the sum through 9 terms. And what I mean by that is, do I have all the pieces I need? So I know the first term. I know I just found the ninth term, so I can use that in there. And I know n is 9. So I have everything I need to do this. I could do it either way. It would come out the same, but I'm going to use a little simpler one over here. So we have 9 for n over 2, and then it's the first term plus the term we're interested in, the ninth term. And the first term again was 3, and back here we found our ninth term was 59. And so doing that out, the sum through the first 9 terms would be 9 halves of 62, and then reducing a little bit there, the sum would be 9 times 31, just canceling the 2, and if we multiply that, the sum through the first 9 terms would be 279. So that's if I wrote out the first 9 terms and then added them all together, it'll come out to 279. Okay, so question 5. This one's a little trickier. So if a sub 4, the fourth term is 3, and the 20th term is 35, find the first term, the common difference d, and the sum through 40. So to do that, if I know, so we know there's a common difference, right? So if I knew how far apart the terms were, and I divided by the number of terms that they were apart, so say the total distance between them was like 10, and there were 5 terms there, then the common difference would be 2. So that's what I'm going to do here. So it looks a little bit like finding slope, which is actually kind of what I'm doing. So we're going to take the difference of these two values. Actually, let me write out what I'm going to plug into, and that will help you see. So I'm going to go the 20th term minus the 4th term. And that's going to tell me how far apart these terms are. And then I'm going to divide by the number of terms that is. And then that will give me the common difference, much like I said, if the common difference if the difference between the terms, the two terms was 10, and there are 5 terms, then they'd be stepping up it by 2 every time. So that's kind of what we're doing here, and it's actually going to come out to 2. So this would be, the 20th one is 35, and the third one, or the fourth one is 3, over 20 minus 4, so that'd be 16. So this is 32 over 16, or 2. So I got my common difference, and now I need to get my first term. And to do that, I'll use the nth term formula. Let me jot that down right here again, so you can see what I'm plugging into. And I need, I'm looking for the first term, And they gave me two other terms, so I'm going to use one with a little bit smaller numbers. Over here, I know when n is 4, then a sub 4 equals 3. And so pretend like that looks more like a 4. So here I can say the fourth term is 3. I don't know the first term, that's what I'm trying to work out. But I know that's true when n is 4. And then back here I know my difference. And so that's going to let me solve for a sub 1. So this will go 3 a sub 1. This is 3 times 2, so that's 6. Subtracting the 6 over, I get the first term is negative 3. And we can get negative values in these, we just can't put in negative numbers. So our counters are going to be 1, 2, 3, 4, 5 to infinity. But the outputs can be negative. And then to find the sum, come back here for a second. So I could just find the 40th term really easily using this and then plug into here. Or this one requires that I know the term, the first term, and the difference. So I could also use this one. So either way, I'll use that second one. Actually, let me write that down here so you can see what I plug into. So this is going to be Sn equals n over 2 a sub 1 plus n minus 1 d. So S sub n, and in this case it's going to be a 40, equals 40 over 2 times the first term, which I now know is negative 3, plus n, that's 40, 40, minus 1, and then times the common difference we got way back here was 2. So now I just need to kind of grind out this arithmetic. So the sum through the first 40 terms is going to be 20. This is negative 6 plus 39 times 2. And let's see, 39 times 2, that's going to be 40 minus 2, 28, 72, I think. Check my notes, yes. And then 20 times 72, so that's going to make the sum through the first 40 terms 1,440. So for number 6 we're given, the sum through the first 34 terms is 1921. We know the first term, we know it's an arithmetic sequence. Find the difference in the 30th term. And so kind of looking at my formula choices, this one has the first term, which I know. It has the sum, which is, once we see sum, we know we're using one of those sum formulas. So we know this side, we know n is 34, and so the only thing I don't have there is d, which is what I'm supposed to find. So I'll go ahead and plug the rest of this information here, and then I'll solve for d. So this is going to be 1921 equals 34 over 2, and then 2 times a sub 1 is 7. N again was 34, and that's going to let me get at d. So this is 17. Let me clean this up a little bit and then I'll solve. And this is 14 plus 33d. So I'll divide that 17 over, and that gets me 113 equals 14 plus 33d. Subtracting the 14 over, I get 99 equals 33d, and then d equals dividing 3. So that's the first thing they wanted me to find. And now they're saying find the 30th term, so that means we're back to our nth term formula. And so that was a of 30 equals the first term, plus, and then it goes n minus 1, so 30 minus 1 times the difference, 3. And cleaning all that up, I get 7 plus 29 times 3, and that's going to be the 30th term is 94. So even if you're not quite sure what to do with these, there's, in this section, there's only 3 formulas. There's 2 versions of the sum formula, and then there's the nth term. So once you see you're finding, the nth term, you know you're going to be using nth term formula. If you're given the sum as a part of the givens, you know you're going to use one of those two sum formulas to get at something. And so just sort of by reading the directions and figuring out what you have and what you need, you can kind of focus in on which of the three formulas is the one you're working with. And then last one for this section, find the sum of the first 100 terms of the sequence 4, 9, 14, etc. And so we know A is 1, and we know D is, oops, I didn't actually write it. A sub 1 is 4, and then D, the common difference looks like it's 5. And so I have, I could find the 100th term and then use the little formula, or I could just use the slightly more complicated one. So I'm just going to write out the more complicated one more time and just plug straight into there. But you could do that either way. So there's that one again. And I know n in this case is 100 because we're finding the first 40 terms. So we're finding the sum through 100, and that's going to be 100 over 2. 2 times the first term, which is 4. 100 minus 1 times the common difference, which is 5. And then just kind of cleaning all this up, I get s of 100 equals 50. 8 plus 99 times 5. And if we grind that out, the sum through the first 100 terms will be, let's see, I got 25,150.